Okay.
You did great, Justin, as well.
Good to go.
Okay. Hi, everybody. Sorry about that. A little technical difficulty, but here we are. So welcome to the last panel and discussion of the day. Today, we're going to talk about new advances in test tools for C V2X. So I'm Justin Johnson. I work for 3M, and you guys might know 3M introduced one of the original test tools back at the onset of DSRC, and its use is to help kind of provide designers, testers, operators with the ability to test protocols and to see data transmitting from OBUs to different units and really evaluate what's working and what's not working on their devices. And so I'm happy to be here today with Bill McKinley and Gerd Schmitz. They are representing some of the next generation of test tools that also have integrated some CV2X capabilities, testing, and conformance as well. So I'm really excited to have a discussion with them today. We're going to start out with with a presentation by each of them where they can talk about what the devices that they're developing or have to offer and some of the capabilities and functionality. And then we'll move into some Q&A session afterwards. So if there's any questions that come up during the presentations, please type them into the Q&A. Go ahead and take a look at that now. If you have anything that comes up, we'd love to be able to answer some live questions and really facilitate a good discussion. In addition, the panelists have come up with some polling questions that we'd love to hear your input on, and as well, you could have a chance to see what some of the other people attending the talk are how the answers are kind of grouping together as well. So we'll check in on those kind of throughout the hour here, and look forward to a good discussion. So without further ado, I'd like to kick things off and introduce Dr. Gerd Schmitz. He is the CEO, co-founder, and owner of S.E.A. GmbH. He's been active for scientific manned and unmanned space missions operations at DLR, the National Aeronautics and Space Research Center of the Federal Republic of Germany, since 1987. Before founding the S.E.A. in 1995, Dr. Schmitz has completed his master's thesis in physical chemistry at the University of Cologne, Germany. The focus of his responsibility in S.E.A. is strategy and planning of test systems and software, including test solutions and products for wireless electronics, especially for the field of V2X, connected car, and autonomous driving technologies. So I'll turn it over to Gerd.
Yeah, Justin, thank you for the introduction. Welcome, everyone. So I will start with the presentation of our test tools. And as we are not as known as Keysight, there is a very brief company introduction. So what is S.E.A.? S.E.A. is a system engineering company. Traditionally, we are on the market since around 30 years now, doing a lot of things in the past, and we are focusing in one branch on wireless testing technologies since about 15 years, and V2X now since 5 years. We have our own hardware and software products as well as customized solutions. Since our beginning, we are working quite closely with National Instruments, and we are using their platform heavily as well now in the V2X area. So that should be good enough for the introduction of the company. Now moving over to the V2X direct connected traffic. I think that is one of the specifics of V2X, which is probably known to every one of you, that V2X is about direct communication independent of DSRC or 802.11p, which is a difference between V2X and mobile networks. So what do we do? So our goal and our portfolio now covers the full range of V2X testing. So depending on where you're from, what you're working on, you might have very different topics that you need to test. And on this slide, you see very symbolized the layers that people cope with when you talk about V2X. So starting at the RF layer, the protocol layers, the ITS layers, the signaling layers, and finally application and the use cases related to them. And we have set up a set of tools and solutions which cover all these areas. So starting with the low-level RF stuff, channel emulation, for example, or RF measurements and conformance. Then moving over to the protocol tests, the newest activity here is sniffers and loggers, and I will come to that some slides later. And finally, for testing on application level, you need open or closed loop test systems, and not to forget also test catalogs, which already implement the tests that have to be taken for the different use cases and applications. We support 802.11 DSRC as well as LTEV, and we are using software-defined radio technology here, which gives us a lot of ability to implement customer-specific things or additional features, which are quite unique in the market. So which fields do we serve with respect to the application? We serve in-lab testing, with respect to conformance testing on RF and protocol layers, application layer testing, scenario-based testing, interoperability testing. So these are the classical applications taken in the lab. Here you see, for example, a RF compliance system in this image. Then, and that was topic of a keynote talk yesterday, we think in-lab testing is fine, but it cannot cover everything. Monitoring and test track testing is still required. And with our tool set, we cover this as well. So we have sniffers and loggers available. And finally, if drive testing is needed, so really recording the relevant data, not only V2X, but also CAN bus and GNSS information, we provide tools with that. And we think with the portfolio, we cover the in-field and the in-lab testing completely and quite seamlessly. So moving over to an example of a test system, that is a system you've seen in small, which is now at the Malaga side of the OmniAir Plugfest. So this is a full-blown, this is not the complete equipped system, but this is a full-blown test system for the 3GPP or OmniAir C V2X test. It runs automated tests. It can be operated manually. It includes a GNSS simulation, the V2X measurement unit based on a NIVST vector signal transceiver. It includes the high frequency 27, 26 gigahertz signal analyzer and transmitter so that we can perform the complete test suite of the 3GPP definitions for 36.5211 and 5213. As I said, it's available in Malaga for testing. Now, not to make the time too long, Bill is waiting. There is also a sniffer available in both sites, in Austin and in Malaga. Randy from OmniAir, Randy Roebuck, yesterday had some first impressions on using it in his presentation. So the specialty on that sniffer that we have here is it's a software-defined radio-based sniffer, and that enables us to do some other things like just receiving messages. We can also, or we do process some received messages, and we also can provide the information about the RF parameters, the subchannels, and so on with each message. And with the sniffer, it is set up to work with Wireshark, which has specific dissectors in there. As I said, this is available on the sites and can be seen there or used there. This sniffer is a first product, quite compact product, which can be used in the car or in the lab. Integrated software-defined radio with a PC from NI. With this, we can record messages and additional RF parameters and visualize them as well. We are working on a basic sniffer, which is based on a chipset. This will be limited in function. This will have the typical function of receiving the messages. In addition to the sniffers, we will have loggers for drive testing, which also are able to record CAN, which can record GNSS and LTEV or 802.11p messages. And there we will also have a chipset-based logger, which is limited in function, and we will have a software-defined radio-based logger, which is able of recording the same signals, so the V2X, LTV, or 802.11p messages, as well as GNSS and CAN, but we can record LTV and 802.11 on baseband level, which means we can store the IQ data, and you will see that in the next slide or one of the next slide. We can also do a replay in the lab. This will also be more ruggedized and more mobile with additional batteries and communication interfaces. Now, Sniffer generates data, or Logger. We also have a platform, but that is just a glimpse of what it can do about managing this kind of data. This is not managed in Google Maps. It can use Google Maps or here or other map providers, but that is a very scalable system that we are using currently already for mobile data drive testing. Here are some examples of visualization. And if you are interested in that, just get in contact. That completes the portfolio finally. Once data is generated, you have to deal with it in a way, and that is our proposal on it. A test system, a functional test system, can look quite simple. So this is a functional test system for typical application kind of testing. Again, here you see a PXI system from NI equipped with CAN bus, GNSS simulation, and V2X, and a software-defined radio, which is hidden in the case. And what you typically do with these systems is you simulate the V2X environment or the other traffic objects in a simulated scenario. You simulate the GNSS on RF base or signal base, and you have some communication with the DAT, some in-vehicle communication by CAN bus or other things. All these are coordinated, very, very synchronized, very deterministic, and putting that in a more detailed level. What you see here, what I just explained to you below here for our open loop test system, you have the scenario simulator. Here you see CarMaker, for example. From this scenario, we generate the packets which would be in the air for V2X, so all the messages being received from other cars which are in the vicinity of the scenario, the GNSS route and the CAN. A very specific thing is we can do congestion simulation up to 100% channel load. So theoretically up to 2,000 cars with C V2X with just one radio in this small system you've seen. And that is a typical lab environment for functional testing. Now extending that with a logger, we can use the data recorded by the logger to immediately have the packet streams available for replay, or that's a future activity, we will be able to have the RF recording on IQ level and do the replay here directly without going through the message layers. So simulating or emulating the reality as close as possible to the device under test. So the scenario-based testing, the last two slides, it's basically, as I mentioned, we can do open loop, what I just explained to you, doing a replay, not respecting the responses of the device under test in the scenario. That is one possibility we have in the system. The other one is closed loop. It's based on the same platform. Here we do real-time model calculations every 1, 10, 20 milliseconds. Here we are using CarMaker. In the real-time environment, we are using the same communication based on software-defined radio, but here we have the closed loop, so we can do driver in the loop things, we can do cooperative V2X or other scenario simulations as well. Finally, I mentioned that already for application testing, we do have the test catalog, so we implemented the typical test cases of the day one use cases for the different regions. We support US, China, and Europe. We do have the relevant ITS stacks in our test systems as well, different ones for the different regions. And we have already a prepared test catalog, which ends up for the customer by selecting the test case, maybe changing some parameters to the needs of the customer, pressing start, and you get a protocol at the end. So thanks for your attention. I think I made it in time. That's good for me. So what we present is a quite comprehensive tool set to our mind. The software-defined radio implementation gives us a lot of flexibility and possibilities. We do have turnkey solutions, really starting on the top level with the test catalogs, and we do have the sniffers, which finally combine the in-lab and in-vehicle testing and drive testing to build up one homogeneous test environment. And if that is not enough, we are still able to have adaptations here for specific needs. Just had a call with the OEM asking for some specific. That is since 30 years our core business. And yeah, if you want to get in contact with us, I would be happy if you call me or drop me a mail. And thank you for your attention so far. So I'm finished.
Thanks, Gerd. Thanks for the overview of S.E.A. So next up, we can have Bill set up his slides. In the meantime, I want to remind everybody about the polls, that if you click on the polls tab underneath your name on the right side, you can see the questions that have been posted there. It looks like a few people have started to put in answers, and that's great. We can look at those as the results are coming in, and just see kind of where everyone lies. And I think everyone can see the results once you've selected some answers. So so with that, let's talk. Let's have a quick introduction from Bill McKinley. He spent 30 years working on wireless communication, starting with Hewlett-Packard, followed by Agilent Technologies after the HP spinoff, and most recently with Keysight Technologies. His current focus is developing innovative test solutions for the automotive sector as wireless communications transforms the industry. He represents Keysight in various working groups in organizations such as C-V2X and Omniair, and is regularly invited to give presentations or take part in panel sessions. Bill has held multiple engineering management positions throughout his career, including R&D, strategic planning, marketing, and manufacturing engineering. Bill is currently Keysight's Connected and Autonomous Vehicle Strategic Planning Manager. So with that.
Okay, can you hear me okay, Justin?
I can, yes, Bill.
All right, good, thanks. Okay, I'm having trouble sharing the screen. I don't know if Gerd needs to unshare or something.
Let me check that.
Okay,
he's gone now.
Okay, thank you very much, Gerd. I appreciate that. Let me just do
sure.
this. Okay, I'm going to share my screen. Okay. Yeah, so hello everyone. Good morning, afternoon, good evening, as most people are doing these days. We have a kind of global audience. Yeah, so very nice to have the opportunity to talk to the Omniair team. So I'm going to show a few slides of the Keysight solution for cellular V2X. As has been mentioned before, we have this set up in most of the test labs around the world. This week is in Decra in Malaga in Spain, who are using our machine as well as others, as Gerd mentioned. I think they're using the Sniffer from S.E.A. And so things are going pretty well. I'm checking in with our lab guys who are on the team viewer sessions every day. So let me just quickly give you an overview of our solution. So here's a picture of it. It's based on what our platform we call our UXM platform. This is our UXM 5G platform. And we developed our C V2X, even though it's release 14 at the moment, on our 5G platform, because we're all looking forward to release 16 and 5G NR and the side link coming pretty soon. So our core instrument here covers both the UU interface, so vehicle to network, so the essentially connection to the base station. So the UU and also the direct connection PC5 includes the stack. So we cover the physical layer, the stack, as well as the application testing, and we'll come to that shortly. And so it comprises of components such as our UXM 5G platform, GNSS emulator. Of course, GNSS is required for both synchronization and geolocation, and some software that we'll come to in a moment. So I thought I'd just give you a quick demo of what this thing looks like. So you're going to see it in action, those of you who are not in test labs. So here we do cover a bunch of stuff in Keysight, but the C-V2X solution is based on our cellular platform. It's based on our 5G platform. So this is some kind of early stuff. So what we can do is we can simulate traffic scenarios at the application layer. We'll come back to that in a moment. Here's a typical screen where we can see a whole bunch of things going on. So the top right, we have a couple of vehicles in play, communicating with each other. We see a spectrum display. This is adjacent channel power. We can see the transmitter of the vehicle under test, trying to find free RBs to transmit on, so it's moving around a little bit. We see data throughput. Here we see another scenario. This is in New York. We see a scenario being played out. There's a police car chasing a vehicle under test. We can look at the transmitter again on the device under test. So here, constellation. We can look at EVM. We can look at power versus time. We look at the packets in the channel being transmitted. So there's quite a lot of information all going on, all available simultaneously. We can zoom in, and on the right side you'll see our data logger. So we can look at all the BSM, CAM, denim, BSM, SPAT map messages. We can have full logging capability. And then finally, again, going back to the New York scenario, we're able to then have congestion tests. It's a kind of stress test. So you can look at, we're simulating many hundreds of vehicles. And at the same time, you can see the channel, which is getting pretty loaded. But we'll see in a moment, we've got the same scenario going on, the same police guy chasing the vehicle, but in the presence of many hundreds of vehicles. So we're able to set up these different scenarios in any location around the world. We cover the ITS stacks from US, Europe, and China. And so we can create these things. So from PHY all the way up to application layer. And we do this by creating real world scenarios, as we saw in a kind of mapping software. We download this into our instrument. We set up the channel, PC5 or UU. We essentially play out in real time the device under test. And by doing so, we can save a lot of time by trying to do this in the real world is very, very difficult to be repeated, but can be very expensive and vagaries of weather and so on. And so here's a picture of it. We have, I've mentioned our two instruments. We have software that can run either on an external PC or actually inside our instrument, so very compact. Keysight was the first to achieve 3GPP GCF validated test cases for radio conformance test. We also cover PCT as well. And then we've got the industry's leading number of 3GPP test cases validated by GCF. So we're very much in the conformance area, but now we're moving up the stack, if you like, into the Omniair test cases. I mentioned we are able to do some stress testing, like a congestion and so on. I'll maybe pass on to the setup that we're having in the labs around the world. So we have our UX and 5G platform, GNSS, and we have the Omniair test cases. And we connect everything to a device in our test, and we can remotely control the device by various interfaces to get the device to do what we like to do, including TCI, which many of the Omniair members know about. And we're compatible with TCI v3, although we haven't seen any devices with the version 3 support just yet. Maybe later this week. So we're able to cover all the stacks. So physical layer. So this is the GCF or the 3GPP conformance tests. We have a full system rack that is validated and is used by many of the test labs around the world. We have a minimum system that doesn't do the out-of-band stuff, if you like, and then we go up the layers and we have in this PlugFest, the Omniair test cases. And we have various options. So we have the upper layer testing that are available, including optional application testing, congestion, and so on. Or if you're just interested in the physical layer, then and you don't need the upper layer stuff, we do have the RF tests fully automated for as per the Omniair. So if you're just interested in modem or RF, then we have that capability as well. Okay, and I think that's it. So I'm going to come back and stop sharing and hand it back to Justin. And thanks very much for that opportunity.
Okay. Yeah, thanks, Bill. Thanks, Gerd, for the introductions. So at this point, we'd like to start to have a question and answer discussion. And so I'd encourage anyone who has any questions, if you haven't already, to post some in the Q&A. You can just click the tab on the far right and click Add a Question and go ahead and type it in there. And if we'll be happy to answer live questions about either of the test tools capabilities or really any other testing or certification type questions that anyone in the audience might have. And it doesn't look like we have any in there yet, so I can start off with a couple questions that I'm curious about. I guess first for everyone, we're concerned with North America ITS protocol stack during this plug fest, but just generally, does your equipment support other regional variants? I know you guys are both not from the US, and so are there Europe or China capabilities, or what sort of protocol stacks do you guys support?
Bill, you want to start
Maybe I'll
this
start
time?
Yeah, sure.
go ahead,
Thanks.
Bill.
Indeed. Our equipment supports the three major regions, which is of course US that we're covering at the moment in Plugfest for Omni-Air, but we have S.E.A. supported stack as well as China. China at the moment, I would say, and maybe Gerd can comment too. China, the standards are moving around. There's a couple of organizations who have actually there's a couple of variations on the same standard. They don't quite interoperate, so we actually have had to develop essentially a translator. So we're compatible with both kind of main standards of China stack. But I think in China, the situation is still evolving. But at the moment, we are compatible, so we can cover the major regions. So I'll pass it over to Gerd. Perhaps you can comment.
Yeah, so I can completely confirm the dynamics in China. So the situation for somebody not being from China looks a little bit complicated sometimes. So you have the CSAE and you have the CCSA. We also have, so we support the three major regions as well, and especially in China. We are now working with a Chinese stack provider also to support the dynamics of China. So it appears to be helpful to be able to read Chinese and to speak Chinese and to be right off the door of the standardizing committee. And I hope we will have the first demonstration on that integration by the end of next month in Beijing, I guess, together with our partner. And that is our general concept in the test environment, is to be able to exchange stacks, because things are not fixed, things are moving, and China is the best example for that at the moment. And sometimes the tier one may not want to test with a stack he is already using. So you want to have another stack which would add a level of interoperability. And that is part of our design to be able to exchange the stacks which we are implementing in the test system.
Okay, interesting. Yeah, so you mentioned standards that are sort of under development, changing, growing. So can you guys comment a little bit on what's happening with C-V2X standards, both in the US and worldwide? And when do you expect decisions? I mean, particularly from the US government, but also if there's other other areas that are sort of working on new ratifications or changes. Gerd, do you want to start?
I can do. Maybe I cannot give you a satisfying answer, but at that point we are in a political area. I think it is not that much a technical discussion that is going on. Both standards work to a certain extent. Maybe LTEV and C-V2X has more dynamics at the moment. It is younger, so maybe there are one or the other things to be experienced, but basically both work. So we are not right now in a situation where we need political decisions, which are obviously very hard to get. So China, it appears to be simple. In the democracies in Europe and in the US, it appears not to be simple. So in both regions, we had already decisions on the table. In Europe, it was stopped. In the US, it's still under discussion what to do. And I cannot give a time scale here. If you would have asked me 3 years ago, I would have said next year. I can say next year today, but who knows? I don't know if Bill has a better glass ball.
No, I wish I had. No, the glass balls are pretty cloudy all over the world, I think. But yeah, no, I agree, Gerd. I think from a technology standpoint, I mean, I think we started off in DSRC as well. We have a DSRC solution. That's where everybody started. We're now moving into the C V2X. I think the momentum seems to be with C V2X at the moment, notwithstanding the political situation. I think everybody's looking forward to perhaps advanced use cases, 5G. There's a lot of cachet around 5G, what that's going to bring. I think in general, release 14, where we are today, kind of brings parity to our DSRC, so for basic safety messages. But the advanced use case with sensor sharing needs the bandwidth, the low latency, the high reliability aspects of 5G, and we see that coming in release 16. Now the Wi-Fi community are working on their own next generation. So it's I think the technology aside, it's apart from China, they've decided. We have to wait and see what happens. But I sense a momentum shift to cellular format, but I think the markets will determine. And in terms of timing, well, again, China is probably the one where we can, COVID notwithstanding, rely on it. I think they're saying they want to roll. There are many trials going on, so perhaps next year we'll see rollout in some of the OEMs in China, and of course in the US we see Ford, or we've heard yesterday during some of the sessions, 2022 looks like Ford and other maybe OEMs in the US will be rolling out, again pending political situations. So that's kind of the time frame. But as Gerd said, the crystal balls need a little bit of cleaning on the inside right now. Polishing, yes. And I hope that helps.
Sure. So, no, yeah, thank you. And I mean, you guys were talking a little bit about release 16 and some of kind of what's on the horizon. So, I mean, what will be the impact of some of the 5G NR on C V2X? Do you expect LTAA or release 14 still to be supported? And what do you guys see on the horizon from some of the new 5G release? Bill, I guess let's start.
Yeah, maybe I'll start. Yeah, so I think we're in a fortunate position actually, because as I mentioned, our C V2X solution is based on our 5G platform. And the 5G, and we've been very successful, I would say, in 5G. We're in all the leading chipset vendors. We're sending this, we're working on the standard. So we've been working in 5G for several years, and so and from the cellular side, not C-V2X. But what we see is the advantages that 5G brings, and we're all seeing that, or we will be seeing that as it rolls out in the industry. So we see the so-called advanced use cases then become a possibility. And a lot of vehicles or manufacturers are talking about sensor sharing, cooperative maneuvering, and these things, platooning. These things are all, let's say, future. The technology to the LTE Advanced can't really hack it, but 5G NR will be able to. And so there's a lot of hype, I would say. The technology has yet to be proven. That's why companies like S.E.A. and Keysight and others, we need to test this stuff to make sure that it works before it goes out in the real world, because this could be pretty dangerous. These things just really need to work before they're unleashed. And so we're trying our hardest to develop the test solutions that really test the technology. It tests the application, the physical, all the way up to the application layer, to make sure that it's ready. And but the future looks pretty bright. There's a lot of promising slides I've seen, let's say, in PowerPoint with a kind of future vision of what it might be. And I think there's a good chance of getting there. The when is the question, and it needs proven out. But I'm looking forward to some exciting possibilities with the advent of 5G. I think it's going to have a big impact. I don't know, Gerd, if you want to comment or some of the feelings, perhaps.
You had some good words in your comment. So one good word, to my opinion, is hype. I think we're now all working on getting C-V2X or V2X in general on the road to gain experiences in the real application beside pilot projects, which are running since years based on DSRC and also in C-V2X now over years. But the real world application is still missing, and DSRC is a little bit on the road and in some vehicles from Volkswagen. C-V2X is not on the road so far, not rolled out, and 5G is coming and will enable all the additional use cases for sure, which are in the mind of researchers and engineers at the moment. And it will have advantages there because of bandwidth, especially. And I guess the time scale is in several years for 5G. And I'm also quite sure, as I mentioned, we do have the day one use cases, the test catalog for that. It is not just the 21 use cases in China. For each use case, you have 10, 20, 50 test cases because you have to consider all the boundary conditions, the different conditions. So for an example, if you have an emergency braking and you get the information by V2X, it's good to know, but it's also good to respect if this car is braking in front of you or behind you. This would lead to very different reactions from your side. So you immediately have two use cases, or you're standing on a parking lot and somebody is doing a hard brake. You don't care at all. And these test cases really explode if you look into the details. And that is a little bit, I think, the biggest challenge if you're looking to the application of the communication technology and the possibilities. You will get such a big permutation number of test cases because of all the things you can do, of all the information you get. This will be a challenge, and that will need some experience to really judge what is a good application and what is a bad application in real world, what helps and what generates more problems than it helps. And these are the timescales which are ignored typically in media and press and technology releases. And I guess going through all that will take years. So I think rolling out now and starting is a very important point. And politics should decide here because without that, we cannot get the experience we need to do the better things. And V2X will be, I think, a mandatory part of autonomous driving because it is a different kind of sensor providing different informations. So once we really seriously talk about autonomous driving cars, we should have a V2X being operational, reliable. And that is the point we really need to start today with it. And then we need to think about the advanced use cases. That would be my mandate on that.
Yeah, good point. So you mentioned some of the use cases, some of the complexity of testing some of those, and I mean that is almost an overwhelming thing to think about. So can you guys briefly explain how your test equipment can be used to test the application layer in some of the day one use cases? Gerd, why don't you go first this time?
No, I can start quite quickly. So as I said, we found that this is one of the points for the customer as well, that you have to find out which use cases are there, what might be the boundary conditions, the parameters to be changed. And that is why we have brought up and implemented the test case catalog so that the customer really can start right away. What it contains, the test catalog for a typical in-lab system is a scenario, so some simulated environment, maybe on a real map, maybe on a abstracted map, things that Bill showed in his presentation. You put up some cars on the road and you put the device under test into one car virtually. So it believes to be in one of these cars, receiving the messages from all the other cars, knowing about its internal situation, so its own acceleration, brake situation, position, and things like that. And as it gets the physical signals for GNSS V2X and its internal status, it believes to be in the situation, and you can simulate this scenarios for the use cases. So you can have the car behind you braking, you can have the car in front of you braking, you can have two cars coming on the opposite lane in the counter direction, and you have the car braking on the counter lane, on the other lane, and which also normally does not affect you. So you put up your world and you use that for the application level testing. Now, this is very good if you can do it in the lab, because you can simulate things which are critical, which you don't want to do on the road. So I remember 2 years ago being in a vehicle from Ford on a test track, and the driver showed us how his yield assist works and how he brakes if he knows there is another car coming from the right. But I think the driver has some sweaty hands. So these are things you can do on the track, but you don't like to do it, actually. At least you want to validate it in the lab before you do it on the track. And that is the task of these use case testings. And you need to do both. You need to do it in the lab, definitively, to save time, to save money, to save cars and models. But then you need to go to the test track and do the same and analyze it based on recordings you do on the track.
Yeah, maybe just I can't really add very much. I mean, it's very similar. We have a kind of similar approach. You know, we create these scenarios, these day one use cases, as Gerd mentioned, and then we can play those out over the RF to the device in the test. We can monitor the reaction. And as Gerd said, you know, you want to really do some dangerous maneuvers in a virtual world before you go into the real world, because you know, things can happen, and it's also very hard to repeat it. As an example, in Malaga, where DECRA is holding the Plugfest, they have a test track with buildings and simulated test track. We actually recreated that test track in our software during the last Plugfest, and so we were able to carry out. Because there were some RSU problems, some hardware, but we were able to essentially simulate in the same test track. We were able to get the maps and all the conditions. So we were able to do accelerated tests, braking tests, all in the virtual world. So it really helped out. So yeah, so we can really test out the performance safely and repeatably with accurate measurements at the same time. Yep.
Okay, yeah, no, thank you. I think that's a really big need. It sounds like, you know, doing some of the, you know, the ADAS testing simulation in order to integrate that capability really adds a lot of new value that in the past has been well, certainly wasn't supported. And so I can also think of, you know, other tests. You know, what additional tests can your equipment perform to fully test device performance? Bill, what kind of other?
Yeah, well, I mean, as maybe Gerd mentioned, you know, and there was a really good presentation from the CTO of NXP just before this, and he's talking about, you know, how the vehicles of the future, with the end goal being the fully autonomous vehicles, right? I guess everybody's trying to get to fully autonomy and all the benefits of that. But you know, the sensors that a vehicle has kind of adds this. He called it superpowers, which is really pretty nice. You know, see, vision, X-ray vision. Well, we have radar that cuts through snow and ice and all that. You know, and then for sensory perception, non-line of sight V2X gives you that. So vehicles coming blindsided at a junction, the car will know that's before you do, so it will brake. You don't know why, but then the car runs a red light. You go, oh, well, thank you for that. And then we have so ADAS, all the sensors around ADAS, so LiDAR, radar, vision systems, and then V2X on top of that. So indeed, V2X, I guess like most people, consider it as an additional sensor to a smart vehicle. So yeah, so we're working on a essentially autonomous driving simulator, I guess you could say, where we take all these different elements and put a holistic view around our device under test, in which case it would be a vehicle. So we have the capability to do that. You know, we've got a lot of history in Keysight on doing these kind of things, so we're pulling it all together. But the C V2X is one of the key components element, but we do have other radar testing capability and so on that we can add to really build up a very holistic approach to testing the vehicles. Gerd,
yeah, so coming from the top down, so yeah, we had the same finding, and as we do not have the size and the potential of Keysight, we founded a consortium together with other integrators for ADAS testing, which is called ADAS IIT, where we have specialists for radar, like we are for V2X and GNSS. We have specialists for radar, LiDAR, and camera. And each of these topics, if you dig deeper, is really, really complicated. And altogether, as we are all integrators, we have integrated solutions. So this would be testing systems on the autonomous level in depth, which requires a lot of physical simulation to the real sensors at the end to make them believe that the car is on the road. With respect to V2X, I would like to pick up one point which Bill mentioned and I mentioned as well, which is this congestion point. I think with respect to performance, maybe that the topic congestion is not clear to everyone. So congestion means finally you have a full road and a full air channel. You have many messages going around, many cars around. Every car is sending 10 times per second its status for V2X, and you have a limited bandwidth that you can transmit. And this congestion is something which needs to be simulated with respect to performance, as all these messages put a lot of load on the onboard units and the RSUs, the roadside units. And this small CPU optimized for cost needs to work with all that messages coming in and to look at it at a different level. So first level would be security. At least find out if it's a valid message. If it's a valid message, find out is it a relevant message. And finally, if it's a relevant message, find out if it is really of relevance with respect to the data contained. And all that needs to be tested in real environment or with simulation of congestion. And simulating 1,000 cars with a chipset is 1,000 chipsets. And that is the approach. I think that's the same approach that Keysight takes there, is to use a software-defined radio capability to really simulate that with an affordable and handleable environment. So that one radio simulates this hundreds or thousands of cars to put the onboard unit into this situation to check for the performance under load situation. And I think that is one of the important part. And the other one, just looking at V2X for sure, is also the RF performance in the sense of conformance, typically. And last but not least, in conjunction with V2X, you have to look at the GNSS and location determination qualities as well. As the position of a message is a very important point to do correct decisions at the end. So where did this message come from? V2X only helps if you get the information there is an emergency car. It only helps if you know where the emergency car is. If you don't know it, you have the same situation like today. You look around and try to find out where the sound comes from. So the position must be there in V2X, definitively, and it must be of a certain quality. And that is also part of performance testing in the sense if you talk about V2X.
Yeah, that's an excellent point. Maybe just add to the congestion. So I guess, like Gerd, as you mentioned, we essentially load the channel with simulated vehicles in the vicinity of the device under test. And we've tested that. So at the plug fit, even though on the air test cases, congestion is not part of the formal testing in the past, maybe for fun or whatever, we've turned congestion on with the permission of the vendor, just to see what would happen. And I would say there've been a few crashes, not literally, but the device has been pretty stressed, and it just shows that when you have 2 or 3 vehicles in a scenario, things work well, everything looks good. But when you load the channel, boy, just as Gerd said, there's a lot of, especially with certificate security, there's a lot of processing, and things happen pretty fast, as we all know. So it's a great stress test. Probably, I don't know what on the air think about having congestion as part of the formal. There's no standard for congestion test, but certainly an important aspect. So it's a great point by Gerd. Yeah.
Yeah, thank you. Maybe we'll turn for the last few minutes, turn to the polls and take a look and see what people have been responding to. So let's start with question number 5. It's interesting if we look which V2X technologies you're currently working on. I guess maybe it's no surprise, but the vast majority of people have selected both. So I guess that just brings the question, do you guys see a potential cooperation of DSRC and LTE5, or do you or how do you see those playing together, or what do you see happening kind of in the forward looking with those two technologies? Bill?
Well, that's just where the crystal ball is particularly fuzzy. you know, it's been clear there's going to be no like interaction between the radio level. They're very different. So, you know, we know dual mode RSUs, so dual mode, dual active, or you know, where RSUs may be able to translate from one technology to the other. It's very difficult for me because how that scales and how just the risk. I'm not sure. So it's frustrating for everybody because, you know, we as test equipment vendors, we want to make sure we're developing the test for the market, for the needs. But when it's unclear, it's not sure. But I guess at the moment, everybody is maybe hedging their bets. We have options for both. We're trying to cover as many bases as we can. We just have to see. So we'll just have to be, flexible on the way forward. I know, Gerd, if your crystal ball in this particular one is any clearer than mine.
No, I think then we're back to the political topic. Decisions have to be taken, and if a decision for the communication protocol is taken, it is a big decision for sure because it affects the infrastructure and other things, and that might also be in certain regions be a point that gives some pro points to DSRC, so that it might win the race there. But if there are some regions in the world or maybe regional which use DSRCs and the other use C V2X as well, then you need this kind of inter-existence, I would say. So it's no interoperability or working together. It's really both are there and the vehicles need to support both. I'm a little bit more egoistic than Bill. As long as the race is open, we can sell test systems for both of the technologies, which is good for a test system vendor. But at the end, no, decisions have to be taken seriously. There will be wasted potential, wasted resources the longer we wait, and that there is no need for that. Just the decision has to be taken, one or the other. There, I'm quite open. And other than that, nothing to add to this question.
Okay, maybe then let's turn back to the polls. We have question number 4 says, when do you think we'll see commercial deployment of C-V2X services in North America? And the results are fairly spread across kind of any time between the next 4 years or further. And I guess that makes me wonder, you know, what is the time scale as to when you'll be able to send a device to a certified test lab for Omni-Air certification? Gerd, do you have any thoughts on or knowledge on sort of when that will be, how that will work?
Yeah, well, for Omni-Air, the definition of the C-V2X test cases was finished, I guess, in July, 25th of July, something like that. So we're moving forward. The test equipment is there. I think Keysight and us, and I think also others have implemented the test cases. On the radio level, all the other test cases are very similar to what is existing already with DSRC. So sending a unit to a test lab would be possible more or less right now, but for sure in 2021. That would be my answer on that.
Bill?
Yeah, I agree. I think, yeah, I agree. I think, you know, the test equipment, this is an evolving picture, right? So things are moving, but, you know, Randy and the team have been working really hard to finalize the test cases. We do have the big giant list now from the air that test labs can take. So I guess it's a question for test labs, you know, like DECRA, SGS, TTA, these labs who are doing the plug fest. I guess once Omni-Air have got the certification, everything squared away, which I think they're trying to do in Q4 or the end of this year, then the test labs will be able to, and then Omni-Air, of course, certify the test equipment, certify the test labs, all comes together like DSRC, then they'll be able to offer the service. So I just think it will be early 21 before we can see that happening. So yeah, I agree.
I would like to add one question to you, Justin. Do you see who answered 2021, politics or technology guys, or were the politics all in 2024? I guess you can't tell.
Right, we cannot tell, but I'm sure that yeah, it's going to be an interesting next few years. I think it's pretty clear to see as some of the as the politics sort themselves out, as some of the decisions start coming back on the table or coming through the through the committees. I think it'll be interesting as as some of the testing capabilities, like you said, the certifications are coming through. Some of the labs will be Omniair certified, and we'll really start to see kind of what some of the changes to some of the RFEs and some of the RFQs come out. So I think it'll be an interesting next couple of years as some of this stuff starts to continue to mature and really all the all the pre-work here that's been going on for a while is really brought to fruition. So I think we're running up on the end of our time together. So I don't know if you guys have any. Do you have any last comments that that we were dying to talk about that we didn't get to in a question? Maybe something quick to wrap up. Bill, do you want to go if you have something or?
Yeah, no, I don't have very much to add. It's been a pleasure, and it's always interesting taking part of these things. We're ready with the equipment. We're looking forward to the rest of the week doing the testing, because that's the test, right? The devices, how they operate, how things go. It's a real kind of status check-in on the industry. So looking forward to working with you, and thanks for the opportunity. Yep.
Well, yeah, final words from my side. So first of all, thank you for the discussion. What satisfies me is that it appears that at least the test system providers go in the same direction. It's quite obvious that there are certain tests and test methods which need to be applied. The ecosystem is building up, and that also enables the technology. And I hope that this has some effect in the near future, that we can really bring this, I think, very important technology on the road. So that's
okay. Well, thanks to both of you for taking the time and being willing to answer some of these really quick crystal ball style questions. I know it's always kind of fun to speculate, but also there's a lot of uncertainty that goes along with it. So I've had a good time being able to chat with you guys. And I want to send a quick thanks to Omniair for allowing us to have this discussion, and for everyone for attending and all the keen listening and for responding to the polls. I think it's great to see a lot of those, a lot of what people are thinking out there. And so with that, I'll turn it over to Kate to wrap up this morning's sessions.
Thank you, Justin. Thank you, Bill and Gerd, for that fantastic presentation. This wraps up day 2 of our very first virtual connected vehicle technical workshop. Thank you all for joining us. We hope that you have found all of the presentations and panels to date to be very useful and informative. And we hope that you'll be joining us tomorrow for the 3rd and final day, where we'll have a focus on cybersecurity. Fernando Rodriguez, Vice President of Business Line Testing for Omniair Authorized Test Lab DECRA, will join us. We'll start the day with a presentation on developments in automotive cybersecurity from the United Nations Economic Commission for Europe, followed by a panel discussion moderated by David Olive, Catalyst Partners on Automotive Cybersecurity in a Connected World. And last but not least, a special presentation from Integrity Security Services, Bill Lattin, regarding identified gaps in V2X end entity security implementations. So thank you all again so much for joining us, and thank you to our sponsors, and especially all of our panelists who have brought us this great content over the last 2 days. We hope to see you all again tomorrow, and enjoy the rest of your day or evening. Take care.